So I was trained as a silicon design engineer, 30 years back. So then did my postgraduate PhD in genetic programming and what we called machine learning back in the days. You don't call it AI because when you call it AI, that time you can't get a job, right? So not like right now. So yeah.
The
So
opposite.
after that I joined a couple of startups before that. So I left the postgraduate. I joined Symbian as one of the tech lead in Symbian OS. That's back when the smart OS was still a thing. Number of things after that. So joined a silicon startup, and which was acquired by NVIDIA. So I was studying NVIDIA for a number of years. Then kicked off two of the, I think, quite important open source organization. One is 96 Boards, which is owning cross-silicon standard body. And another one which was in partner Simplicator, the largest autonomous driving open source organization, Autoware Foundation. So yeah, and we explored the high-level autonomy technology in an open way, unlike many others. So back in 18, so founded the latest company called AutoCore. AutoCore specializing in the e-architecture system software of the new generation of the vehicle. So yeah, that's where we are right now.
Cool. So yeah, let's maybe start there. And would you mind just telling me a little bit more about what initially led you to starting AutoCore.ai and what was your value proposition and how did this evolve over the past couple of years to where you are right now?
Yep. Yeah, absolutely. Yeah. So, AutoCore is my fifth startup. I mean, it was the longest one, in terms of incubation, I suppose. So when I noticed is that the evolution of the EEA electronic architecture of the vehicle has been one of the major but underappreciated at the time, behind the scene of the challenges facing by present a new challenge faced by the OEMs and also the entire values, the supply chain. And that has, obviously there's a lot of new players who has made, immense progress, including Tesla, nonetheless. But the thing is that the reduction, people are, were exciting about the reduction, the simplification of the vehicle and hardware, etc. Instead of an average vehicle has 100 to 120 individual ECUs, now you have Model Y, for example, you have about 25. But that doesn't come free. That comes at expense of the reduction of the hardware, comes at expense of the increased complexity of the software, which was not very well known for automotive industry as a whole, I suppose. And obviously that has made it more complicated or made it possible by the ever increasing capability and capacity of the silicon we use, big or small, So that becomes a bit of a challenge. And how do we deal with the increased complex vehicle software, which many of them called XX.OS today? But instead of comparing with a mobile phone or laptop or PC world, instead of one particularly hardware running on one particularly single silicon, we are dealing with a distributed networking computing environment. That is, in essence, quite different to what we have been facing before, that a single software application running environment has to taking care of entire distributed network, multiple controlling devices. So that is a new computing paradigm, really. And on top of that, we're facing the highest level of functional safety, security requirement because, let's face it, it's life at stake. So that seems to be a unsolved problem, at least the problem, interesting enough to present challenges. And that seems to be something, if done right, we could significantly help not only enable the latest architect evolution of the automotive industry, but many other industry, as we are seeing right now, VOTA, complex humanoid robotics, even commercial aerospace applications, rockets, etc., which has become true, as proven by our existing customer base.
No, thank you so much for the overview. Two follow-up questions to that. One, for individuals not working in the area, what were the major innovations that enabled the progress that you alluded to in EA? And then secondly, what does it mean to organizations and customers in terms of enablement and applications of that?
I think there are, there's a couple of important ones. One One is that we're paying a lot more attention to the vehicle as a whole, rather than focus on individual functionality, function block of the vehicle. For example, a door lock, a warm-up seat. So we're paying a lot more attention on the overall vehicle functionality, so much so that we are using the simplest hardware, as simple as possible hardware, and as simple as possible the network topology to be able to support those functionality. And that obviously has a huge implication, both in terms of the cost, the BOM cost itself of vehicle, and also intrinsically the development integration cycle and validation cycle of the, some of the, for example, we are looking at typically 5 years in terms of a new product introduction in the auto space. Right now, if you look at the most aggressive Chinese OEMs from our customer base, looking at between 12 to 18 months. And that has been very challenging, both for the OEMs themselves, but also the entire supply chain has to accommodate for that kind of speed of innovation. Second thing, which I think is important, is that one cannot ignore the fact that today we are looking at for average passenger vehicle, 100 million lines of code, software-wise. And it's expected that by the end of this century, we'll probably be looking at, on average, 600 million lines of code per vehicle. And that is a huge challenge to deal with, because software has bugs, for one, and the other thing is that level of a software-driven development, so people call software-defined vehicle (SDV), has becomes a norm, and not only a concept, which was not new. Back in 1950s, we got SDV, but right now it becomes reality because of the number of elements which has joined up, make it possible, but also more and more customer user experience to facing content, which makes this not only useful but also a necessity.
Just to summarize this and play this back to you. So what I've heard is generally there is a trend to fewer, more centralized ECUs in vehicles that some of the new entrants like Tesla basically have started with, as I understand, whereas some of the legacy OEMs from traditional sort of ICE vehicles, they still have a much larger number of ECUs and are looking to centralize the architecture.
Correct.
And then in terms of enablement, you said, okay, this will allow us to reduce costs. You mentioned BOM overall reduction there. You mentioned time to market, speed in terms of validation and integration, that will be quicker. And then in terms of efficiency and additional capabilities around sort of ADAS and over-the-air updates, are these sort of some of the major factors?
Yeah, absolutely. I mean, so the OTA or OTA capable vehicle is only one of the first use cases which touched everybody's daily usage of the car, but it's definitely not stopping there. I think it's starting point. If you think about what a mobile phone looks like, 15 years back, I think the vehicle itself becomes quite a loosely defined term. What we tend to think is an intelligent mobility device. Becomes actually not only a one-off selling item, but becomes a platform where you would be safe to assume that a value-added application and service to be provided on top of that, which is mobility related.
And then what really, if we now look sort of across the market, we've of course got quite a sort of diverse group of players. We've got some of the incumbents that sort of, some more slowly, some more quickly try to transition into some of these more modern architectures, also with sort of an increase of their share in battery electric vehicles. Now we've got some of the new entrants, most of which basically started as sort of solely BEV-focused vehicles. We've got Tesla in the US and some others, but then predominantly some of the players from China like NIU, BYD, Xiaopeng, and some others.
Yep.
What are some of the differences that you currently see in terms of architecture out there in the field right now?
Great question. I mean, that is because the way we were set up, that we are able to obviously work with different OEMs and tier ones from different geography and regions. Couple of things. I mean, just from in terms of how we interact with these players is number one is that new market tend to have less legacy and historical baggage, both in terms of their own product development as well as the supply chain comes with it. For example, in China, it's arguably the reason why the speed of innovation is, I think is proven to be really effective and fast. Not only because that it's not only because of other factors, but some of the main reasons is because it does not have so much legacy system to maintain, so much baggage, because the inertia actually within the supply chain is huge. So you can see that the iteration rate is so high. It may be the first generation, the second generation does not come as great. But given time and during the fast iteration phases, the product innovation gets really wrapped up. Compared with some of the European, Japan, and other areas that, so there's much less, what we call red tapes or for example, for those advanced ADAS features, but also the supply chain does not have so much, historic investment they have to protect and recoup, investment from. I think that's one of the underlying reason. And I think that the other thing is it really made it possible, some of the powerful silicon platform and the fact that we're looking at a software-defined vehicle, that you have a lot of features which can be and required to be customized and updated, redefined after sales, which is really a new concept for automotive as a whole. But that has opened up all the possibilities. And I mean, that's, I guess, the advantage of the software-defined capability. But again, that doesn't come free. You have this making sure it's functional, safe, it's secure. You don't subject the life-threatening machinery to people who use it, people who run it. I think those are the things which we see different regions emphasis is on different things, not in particular order. But I think that actually has made a large impact in terms of how the speed of innovation, or how people actually work around. People work around those. But it's one important thing to highlight is here as I do think the industry, regardless of geographic location, are moving towards new centralized EE architecture. But for a long period of time, it's going to be a hybrid. Okay, it's not going to be like what we call in the news, that's a big server on 4 wheels. It's actually going to be a hybrid architecture for a long period of time. That has its own technology reason, but also have the economy reasons as well as supply chain pressure as well.
First of all, thank you. That was super, super helpful. And you sort of already alluded to my follow-up question there, which is essentially around what would all of the experts, or also at conferences, if we hear people like executives from NVIDIA, etc., they all seem to agree what sort of the future of this vehicle architecture should look like.
Right.
Yet there are major differences out there between manufacturers currently.
Yeah.
I was wondering, from your perspective, what would need to happen to enable this future that most experts, executives, entrepreneurs in their field seem to agree on? And what are some of these dependencies from a, for example, supplier perspective that exist that either need to be resolved or at least organizations need to be aware of?
I mean, I think that it's really complicated. I mean, a car is really probably one of the most complicated products human has ever invented. And this is not just about technology, but also in terms of the supply chain and supply network relationship. But I think there's a number of things from technology perspective needs to happen, which I'd like to focus on. Is number one is that there need to be significant progress there on the main silicons, which you use to power those, supporting those ECUs, the controllers. This is especially true for centralized EA architecture. I don't just mean by single silicon supporting multiple functional domains such as smart cabin and ADAS in one, but actually there are a lot more than that. You need powerful silicons with sufficient real-time capability and deterministic characteristic, and also appropriate communication bus capability to implement the zonal controller. And there are multiple different types of zonal controller. You need powerful silicon which are able to help reduce what we call last mile in the EEA. There's a lot of small counterpart actuator still hanging on a CAN and a lean bus. I didn't mean by they are, useless technologies. They are very useful, but these will have a significant cost and integration saving if we reduce those small controller, just by a wire, for example. This is what you see in the some of technology forum, that Ethernet backbone to the node, and also that you need silicons which has proven technology, who are able to handle multi-layer, multiple different category of functional safety applications on one shared physical real estate, which are which is a huge challenge. And also you need to making sure that those traffic, what we are looking at right now, compare with what the vehicle was 5-10 years ago, multi order magnitude increased. Use camera sensor, radar sensor, lidar sensor, all those. And the compute are also very demanding. So how do you making sure, just by adopting the technology we inherited from the ICT world, which is the best effort, does not directly translate to safety and security hazard in a vehicle mobility device? That is also a technology challenge. So I think if you look at the multiple layer, there are challenges pretty much everywhere. So I think this is a trend, and this is not just a trend of racing down in terms of BOM cost. I think this trend will be focused and rightly so for the user experience, and not just one-off, and not just in terms of feature, but maintainability, serviceability, etc. But they're very concrete, substantial technology challenge to be solved. And of course, there are new things come up every other year, which gives us a new opportunity, but also new challenge to solve. For example, we're looking at new physical layer bus opportunity. Instead of the traditional field bus and the Ethernet, we're looking at fiber. But how do you get the cost and also transceiver cost down is going to be another challenge. So I think there's a lot of roadblocks, but I'm conservatively optimistic that we're on the right path of that. Don't forget how we're going to really leverage the evolution of the architecture. Is going to be I'm very convinced it's going to be software driven, and a lot of that will have we will see the introduction of the high level of intelligence in every part of the vehicle, not just the ADAS, not just the HMI and the human machine interface, chassis, and smart battery control management system to maintain the longevity of the battery, etc. So we're going to see that everywhere.
Speaking of high levels of intelligence, everyone is speaking about generative artificial intelligence. And I'll be really curious to get your perspective on Gen AI in the context of architectural developments from two angles. One is, how does Gen AI currently help with the development in terms of architecture? And then secondly, from a demand perspective and applications of Gen AI in and around the vehicle, are there additional demands that Gen AI puts on the architecture that then almost sort of put additional requirements on developers, or from a development needs perspective?
Yep. Obviously, that is a very hot topic in the past few years. If you look at it, to adopt a clever machine learning algorithm in vehicle, in multiple different part of vehicle it's not new, which is very similar to other industries. So there's a smart, profiling technology for how you consume there are multiple different places where the smart machine learning algorithm has been adopted and still being used today. But I think we have learned this in the hard way. I do believe this is one of the very few occasions in the technology history which I was part of, that very few people can do many things for many people. So I try to explain what I mean for us, at least. So we look at exactly what you have mentioned from two angles. One is the process. How is it possible for us to increase the efficiency and the quality of the output of the traditional well-known V-model developments of a vehicle? We weren't sure before. We're less unsure now, because we have been able to involve the latest product we launched called AutoForge. We have demonstrated the possibility of actually not just using AI as a tool, as a co-pilot tool to help you writing code, but actually the entire development process, the V model, is driven by AI. So human expert becomes a helper rather than human driven process. We didn't start there from beginning. I mean, we started by actually trying to, hey, how do we using the tools we have to increase and optimize the every steps on the V model, and we do get between 15% to 50% different type of efficiency increase. But what's interesting is once you actually get to the point where you can automate the entire V model development process, some cases we are looking at a 500-fold. We are 500%, I beg your pardon. So 5 times efficiency, and obviously our goal is 10 times efficiency across the entire. And when that happens, I think that when the efficiency has an order of magnitude of difference, I think we're going to see something very interesting. In our case, every part of a subsystem, we probably only have 1 or 2 engineers now. And 1 or 2 engineers are equipped with, leading like tens or dozens of AI agents we develop. So that is something which has proven to be very, very useful. And that is not just the process itself. And bear in mind that the output of our process are product which has been certified to the highest level of functional safety, ACLD grades, ISO 2626. So that's not only just making things run fast, but actually the quality of that is also guaranteed. But I do want to note is that there's no fantasy there. The large language model, the GenAI capability can help you get to the 80% very fast. Previously, we need to plan it in number of quarters. Now we plan it in terms of the weeks or days even. But you do need a domain human expert for the rest of 20%. Very much so indeed. That's the first part of it. Second part of it is actually the more we deal with it, we found actually it not only just beneficial for the process, but actually it can help you solve some of the hardest functionality problem as well. So within our core stack, we have large language model engine built in, which solves some of the hardest problem in terms of, for example, breaking down a complex action or user aware actions into from QM to ACLD, different function safety category of sub actions in terms of sent to different control. So what I'm trying to say is we're actually witnessing a glimpse of the future that is what we know as operation system, application running environment will be much less focused on the functional design, but focus on the intent of the user. And the rest of it will be dealt with multiple agents which powered by different type of foundation model.
You mentioned the improvements there in terms of efficiencies around sort of X improvements. If we look at improvements across the sort of V model, what types of use cases enable these significant efficiency gains that could, like for incumbents, really fundamentally transform the time to market? What types of use cases are we talking about? Where do these solutions come from? Are there sort of in-house developments? Do they come from some of the larger providers like Dassault or entirely new organizations? Just to sort of demystify this a little bit for anyone who isn't sort of directly working in this space.
Yep. Yeah. I mean, obviously that if this is of interest, you're welcome to take a look at, I mean, this is not an advertisement, but feel free to take a look and try the AutoForge product, which will be officially launched on the AutoCore.ai website. So that's probably getting, the more hands-on feel. But I'll give you some of the examples of the use cases. For instance, when we are developing a functional safe, ACLB or ACLD grade of subsystem, and that subsystem is no longer focused on one particularly ECU functional domains, which will be spread out on multiple ECUs as defined, as one of the benefits of the centralized EA architecture. So you've got a central computer, 1 or 2, you've got a multiple zonal controller. But that's not how the vehicle feature spec is written. I mean, when you look at the layer 1, layer 2, layer 3 different feature requirements from the from the product manager of the OEMs, how we get from the original, how you get from the original vehicle feature system requirement down to the component, software and hardware requirements, get to the architecture design, the software design and hardware design, get to the implementation of agents. And then you're going up of the V model on the right of the unit test, integration test, then all the way up to system test. So that is the workflow we typically work with. And that will have multiple different teams involved across the OEMs and their supply chains. Every step of that is very time consuming. And a lot of that are knowledge which is scattered around. In fact, we have demonstrated possibility you would be able to define multiple different agents at every step. So the output and deliverables from each step becomes agentic generated, not human generated, but agent. And that process, which you can simulate it not once, 10 times with overnight. And the output of that, which will then be looked at by the experts. And actually what we've done is the output of that will looked by another set of agents, which have their own knowledge database and knowledge base, which are trained to look at the output from the first set of agents, frontline agents. So once you're able to iterate that, you will be looking at the development cycle in a completely different manner. Being a documentation, being the code itself, being integrated, being the test grid, being actually the simulation of the hardware in the loop, so hardware and software in the loop, and the vehicle in the loop. And that presents a huge opportunity for us to increase efficiency. I think that's and on top of that, what's very interesting is that those agents, if you train them with the functional safety, standards, ISO, relevant ISO standard, the SOTIF, the security standard, there's a way to making sure that those agents will safeguard the output of each step to be functional safe and to be secure. So we're really looking at those virtual workers becomes what we define as a software factory. Obviously, this is not new term, but actually factory with the worker, represented by those agents are very skilled, and also skilled can be trained and retrained on the job. And so that's something which I think is going to have potential to disrupt many areas. For example, see this probably the need for dedicated software service house is going to disappear very, very soon, if not already. So, but I also still want to emphasize this does not mean we're going to lose the job altogether, every one of them. But actually, they're going to be elevated in terms of the job definition. We becomes a human expert, which are essential and necessary to complete the rest of 20%. Becomes a product viable.
How quickly, what's your prediction on how quickly we see a sort of larger scale deployment of these solutions across sort of a larger number of OEMs?
I think it obviously depends on the region very much. Well, when I say region, I mean different market who has a different appetite for new technology. But I think all in all, I think it's a shared view. It's just automotive industry being one of the most conservative ones does not take everyone, taking the innovation the same way. But I think this is something which has been happening over past, especially last 5 years already. I don't think they are. So I think it's already happening. I think they are really happening and happening very fast. But some area faster than the others. For example, pretty much all of the HMI interface have some element of AI capability in it. Not only just as a big server in the car, but actually some of the edge AI capability in your DMS unit. They're very much already being largely adopted and used, and has some of the very positive, customer end user feedback. I don't think it's probably will have a higher level entry, in terms of resistance for higher level functional safety subsystem. But I think all in all, I don't think this is something in the future. This is happening right now, already across multiple OEMs. And Chinese OEMs certainly are not afraid of trying this, finding the differentiating value for very competitive market in terms of the car user. So I think it's already happening. The real question is that how wide and how soon the new use cases and new features, killer features, is going to be identified for different type of vehicles at a different cost bracket.
As a final question from my side, is there anything that I should have asked but didn't as it relates to vehicle architecture or autonomous systems that you consider to be important areas of development or future trends?
Yeah, I think if there's anything that is probably one of the things which stands out is that we tend to I think many OEMs still do the same in our customer base and some of the potential ones is that we carve out the functionality of vehicle and we solidify the separation and the boundaries, not because all those are necessary boundaries and separations from the end user point of view, but because our organization is organized as such. That is how we form our department. This is how we form the team. But I actually think the AI-driven software-defined vehicle is going to present challenges which worth considering is whether the current organization structure is living up to the latest challenge opportunities presented by the technology opportunity created by the technology advancement itself. I think that is something which we find in reality, in execution, some of the incumbents definitely come from how, in terms of the organization was. But actually, that was supposed to be set up for benefit, to benefit the speed of development, innovation, right, and product development, and it was set up for good reason. So this reflects on that. When I say organization, don't just mean by the organization with a single company, a single OEM or single tier, but actually this organization in the cross industry as well. Cross industry as well. For example, you see the AutoSAR organization. You see many other different similar organizations. They are very useful and beneficial for getting us thus far. But actually, I think we will have to, it's probably worthwhile getting back to the basics is that what would help us building quality, differentiating, and people love product in a fast and a cost-effective way. That has to be, I think, the focus. But obviously, as I said, one of the most conservative segment is not easy, but we really think the genetic AI giving us an opportunity, not only just in terms of what kind of product we build, but actually how we build that product.
On that last point around organizational structures and decision-making processes not necessarily being fit for purpose in the age of GenAI, I think there are many individuals working in the industry that would agree with that. Are there any particular recommendations that you would have for these organizations that feel like we're not quite there yet when it comes to really enabling this decision-making and collaboration when it comes to GenAI, but we also don't really know what to do about it exactly? Is there anything that comes to mind that you would suggest they do?
Yeah, obviously it is very easy and convenient, probably too convenient to suggest that you could just throw the bath water out with the baby in it. Let's start from everything new. Unfortunately, doesn't seem to be the answer most of the time. My experience never was the answer. So I think that's the approach we have taken is taking and respect how the V model was introduced and built up. But let's find a way to increase the efficiency of which, and then step by step building up the possible path that yes, we have inherited the goodness of the V model, but we also seems to be stumbled and invented something new, which could help to get to the end of the product. So people have a confidence and the credibility to see actually there is a new path to that, rather than, hey, you're going to have to listen to me and do things this way, forget about everything you know. That's pretty difficult to swallow, I think, for anyone. Yeah, I think that every organization is slightly significant difference. I don't think there's going to be a one size fit for all, but I would, if there's anything, that's probably two things I would recommend. Number one is don't try to do everything yourself. We have heard this myth for ages decades in the industry is we build everything ourselves. Nobody does that, especially for this industry. Uh, let the professionals do the jobs and do what they're best at. So find the best partner and suppliers you could. I think that's probably going to be, I think the definition is probably even more so in the AI age. I think that's number one. Number two is that quick iteration, even for automotive design, quick iteration and making sure uh, the organization, the structure, development process are designed around that, not the other way around. We leave organize things for the product, for producer better, faster, cheaper. We don't work the other way around of the existing structure, the existing organization boundary, the existing workflows. Let's try to fit the product in there. That probably is going to be very counter-effective, I think.
No, thank you so much for your time and insights today, Yang. That's been super helpful. And yeah, I really appreciate you making time for this.
No, thank you for having me.